So another way to find limit is look at the graph. So remember the table that we looked at earlier, right? The limit, we know the limit is, I'm using the same function. It's not different, I'm using the same function. So limit we just talked about is 2. X approaching 3, f of x is 2, based from the table. So what we can do is that we can look at the table, look at the graph. Over here, you look at what is approaching from the left and this is the y-axis. If you look at this is 1, 2, 3, 4, 5. So keep in mind, this one is actually the y values that you have to look at when you look at the graph. Okay, this is the y values. The number right here, the one that I say x approaching, this is the x values that you have to, that's the location on the x-axis. Okay, what we're going to do is we're going to look what happened from the right, what happened from the left, what values they both approach into. That's what we want to see. Okay, so if you look over here, right here, this is the nice values. So at 3, if you look on your x-axis, okay, 1, 2, 3. At 3, when x is 3, what is the y values? And that is the limit. So at the y values, when x is 3, is 2. So that's how we got the limit at 2. Okay, that's another way. We actually look at the values, the y values. That's when you have a nice function. Okay, when you have a continuous function. Some of you have Miss Conan, then you most likely understand continuous function. If you just took pre-cal last semester, continuous function is that when I draw a function, this one, when I draw it, when I draw the function, I don't have to lift up my pencil. What that means is if I draw this one, I will continue to draw it. My pencil, always on that paper. I never lift it up. That is continuous. Not continuous is discontinuous is when you draw the function. For example, if I draw this line and then I stop and I continue somewhere else. That is what it means to be discontinuous, right? Continuous means there's no hole. The function is just go from one point to the next one. You don't have to lift up your pencil. So to find the limit, another way that we can look at the graph, look at the y values, see what is that values. All right? Questions so far? All right, we'll do the next example. Look at this one. So this one, we're gonna run into where the function is no longer a continuous function. This one is not continuous because you see there's a hole. If I'm gonna draw this line, when I continue on this line, right, I have to stop because there's the hole. If I use the line go over it, then there's no longer there's the hole. This is called a limit when you have a hole, right? And then you can lift it up and continue to draw your graph. This is a discontinuous function, okay? So to find the limit, again, the limit we want to find, let's look at C. We want to focus on this one, all right? That is the limit. Now, it's important that the limit for this function is that approaching from the left and the value approaching from the right should come to the same values. Can anyone would like to guess what is the limit of this function? It's okay if it doesn't have to be correct, but if you have to guess based on what I just explained to you earlier, what should be the limit of this function? So I'm going to write the answer for C. 2. Okay, some of you put down 2. The limit is 2. Yeah, maybe. One, okay. Okay, so we have a couple you say 2, some of you say 1. So here's the thing. The limit, this value is right here. The x is tell you this is the x values. This tell you the location you have to look is on the x-axis. This is where you have to look at 1 on your x-axis. You're going to approach. That is the location of the graph that you look at. When x is 1, what is the y values? That's what I'm looking at, okay? So over here is the 1 is actually the x values. That's the location that you have to pay attention to. Okay, and here, so here's the question some of you would not sure because over here is not defined. There's a hole. It doesn't seem to you that the function is at 2. That is true because at 2 there's a hole. It's undefined. However, the limit, like we talked about this earlier, is not the exact values, but what happened as close as possible, right? So let's get closer and closer to 2. So the answer for this one is 2. That is correct. Now, if you notice, there's a different notation. If you look at A, there is a minus right here, and then there's a plus on the side. I'm going to highlight that one, okay? So that is the one thing is different right here that we want to pay attention to, okay? When we do the practice today, I want you to make sure that you pay attention to that notations, all right? It's important. This one, when you don't have any sign, the plus or the minus sign, this one is the limit as a whole. Okay, the one with the minus is the limit approaching from the left. So the left limit. So I'm recording this. There's a video for you. So if you want, what I'm asking you is you have a notebook and jot down some key information. So when you go back, you can go back to the slide. I'm like, oh, okay, I remember this. All right, so make sure you jot it down somewhere. You may not have the exact graph, but you at least on the notebook, you can write that down. With the plus, can someone guess what kind of limit for the one with the plus sign? So there's nothing, it's a limit as a whole. And then if there is a minus, there's a limit from the left. If there is a plus sign, what kind of limit is that? I'm sorry? From the right. So this should be the right limit. Okay? So if you look over here, if I cannot cover, if in the class, I can use a piece of paper and cover it up. But this is the left side, right? Look on the left side. Look at if it's approaching, that doesn't mean it's going. You see the arrow say going toward 1. So I'm going to draw the arrow that going toward x approaching 1, which is right here. I'm going toward this point, right? As the graph going closer and closer to 1, the y value is approaching 2. The same thing if I'm looking at the right limit, again, how I draw the line is approach and just go toward the location that we want. So we want to go toward the 1, right? Again, the same thing is going toward the same values, which is 2. They both go into the same thing. So if the left and the right is the same values, then there is a limit at 1 because they both have the same. So we'll talk more about that. But right now we're just going to look at the limit from the left, limit from the right, and what happened at that number. Questions from me? Don't hesitate to ask me. Send me an email, message, whatever. Unmute. Let me know. Cool. All right. I need to, all right, let's do another example. Let's look over here. Okay. So remember that you can check by go back and look at the table. All right, there's a function you can go back and check if you don't remember what that is. So let's do final limit. This is the one that we just did. We look at the left, we look at the right, and then we'll figure what happened at 1. All right, so let's look at a different graph and see what happened. Okay. All right, so for this one, again, notice if I have a function, if I have the graph is given to me, I'm going to be honest, I kind of not pay attention to the function that's given to me, like this piece. It's no longer important because I'm just looking at the graph, right? Okay, so this is the instruction. If you look at this instruction, all right, what x values, where is the location that I should pay attention to? At what values from the graph that I should pay attention to? 3, good, right? So we want to look because when x is 3, this is my x-axis, this is my y-axis. So I'm looking at 3, so I'm kind of use that arrow right here, kind of highlight, I'm going to highlight the point that I want right here. That's what I want, okay? So if you look over here on the top with the minus, that means the limit from the left, okay? So from the left, this is the left and this is the right side. So if I'm going to draw my function coming from the left, this is coming toward 3. What values is this approaching to? Okay. All right, so I have some of you said it's approaching 3. When I said the left limit, this is a 3. We get a 3. But we look for, when we talk about the limit, we want to know what is the y value. So that's what I'm looking at. So the 3 is this 3 right here tell you the location. But if you look at my arrow, if you're going to look at my arrow, right? Look at the y value. What y value? What is that value that I'm seeing? 2. Good. Approaching 2. Thank you. I see the message. Thank you, Joseph, Victoria, and Joseph. Thank you. So it's approaching at 2. So the limit is from the left is 2. Let's find the limit from the right. It's approaching from the right, going toward that values. What is it? What is that y value? It's get closer and closer to, coming from the right side. I have 2 and 3. Which one? When I say I'm asking for the limit, I'm asking for the y values. It's 2. Okay. So be very careful. So it sounds confusing, but here's the thing that I want you to pay attention to is that when I said the limit as x approach 3 is 2. So if you can, so if I say this, the limit as x approaches 3 is 2. So you gotta differentiate the two numbers, okay? The limit as x approaching, that is mean if I'm looking from the x, I know which part of the graph I should look at. That's tell me the location to look at. And then when I say the limit is, that is when I'm going to pay attention to the y values, okay? The x is tell you where on the graph that you have to look at. The y value is the answer that I'm looking for, okay? So the x value is just like, it's like the location. Where do I look at? And the 2 is the number that I want, all right? So here's the thing. The limit, if you on the left and on the right have 2, that is mean the limit of the whole thing should be 2. So I don't have to worry about go back and look at it. If I look at the function, if the left is 2, the right limit is 2, then the limit, the whole thing is 2. So that's the answer that I looked at, okay? See, yes, all right. Let's look at some function. Let's look at this one. Can you see the graph clearly from your ends? because like it's kind of like hard to see. But this values right here is 2. This is 4. This is -2. This is 2, 4, 6, 8. -2, -4, -6. Okay. So if you look at this one, we're not going to use the, let's not use a table. Okay. We're going to look at the graph and then we can go back and check to see what happened at the table. Hold on, let me check one thing. Let's see if I have this. Oh, no. Okay, let's use this graph. So over here, I'm going to ask you a couple of things. The limit, the location that you want is say x approaching 0. So we want to look at what happened when x is at 0, which is right here. This is the part that we want. This is the part that we want to look at. That's the location. So step number 1, I'm looking for the limit from the left side. That is mean I'm looking from the left is this piece right here. What happened from the left? What is the limit from the left? I'm going to clear my, erase this because it's kind of hard for you to see with all the numbers. Okay. So the location that I want is right here. This is the 0. That's the location that I want. Okay. So the limit from the left. So x approaching coming from the left, -1. Thank you. Then I would do the same for the next one, the limit coming from the right. That is mean this piece, the right piece coming toward, what is the limit? The limit from the right is, I got the answer from Jessica. I'm going to wait for a few more students. What do you guys think? Okay. It is 1. Perfect. Some of you said 0. Be careful. 0 is the location of the graph to say this is the point that I'm going to pay attention to. This is part of the graph that I want to look at. Once you decide which part of the graph, then you look at the y values. Okay. So the limit from the left is -1. The limit from the right is 1. Before I share my answer, I'm going to ask you to guess what is the limit at 0 as a whole. So it's no longer the left limit, no longer the right limit. The limit at 0. What do you think? Look at my values. I have different answers for the left and different answer from the right. What do you think the limit at 0 as a whole? 0, okay. 9. Okay. 0. Why do you guys think it's 0? It's because it's in between? Oh, okay. I see. I see. The limit I'm looking at is the y values, right? So look at 0. If from the left and from the right, I don't approach the same thing. And so that's why you took the average. Okay, that's fine. However, here's one thing. If the limit from the left and the limit from the right side don't match, that is mean there is no limit at that number as a whole. It's DNE, which what it's saying is does not exist. There's no limit at that point. Okay, so remember the last two examples. When we look, the left and the right always come to the same values, and that is the limit. Think about the table. When we fill in the table, the left and the right always come into the same values. But for this graph, the left, right, the left doesn't and the right does not come to the same number. So there's no limit at this point because they don't share the common values. Question for me on this one. So the limit at this point does not happen. There's no limit at this point, okay? Just think about this. If you go, you're gonna have a date with someone, right? You better go to the same restaurant or the same theater if you want to see a movie. That means the day is happening, right? If you go to one restaurant, the other person goes to a different one, it's not happening, so there's no date. It's the same with the limit. They must come to the same values, okay? So there's no limit. We're not going to take the average. We cannot do that, okay? But that's a good guess for 0. Questions? Okay. All right, we have one limit and have one limit, 1 minute left. So I have a few more things, but what I want to show you is that if you go to Zoom, I'm going to